Okay. The diagram shows 7 circular arcs in a heptagon with equal sides but unequal angles. The sides of the heptagon have length 4. The center of each arc is a vertex of the heptagon, and the ends of the arc are the midpoints of 2 adjacent sides. What's the total shaded area? Okay, so we're going to start with the internal angles of a heptagon, which is, not a line, it's 5 times 180, which is equal to 900. And then we need to find the total if there were 7 completely shaded circles, which would be 360 times 7, which is 2,520. And then to find the difference between these two, we subtract 2,520 and 900, which then gives us 1,620. And then we need to divide that by 360. So 1620 over 360. And then we can cancel out the zeros. And from there, well, we know that 5 times 36 is 180. Yeah. And then if you subtract 36 from that, you get 144. So 162 is in the middle, because 180 minus 18 is equal to 162. Therefore means that 162 over 36 is 5.5. So now onto the total shaded area. We need to, in order to find the area of one circle, we need to do pi r squared. So in this case, the radius is 2 because the length of the heptagon is 4, but the radius is only half of it. So 2 squared is 4. So we have 4 pi being the area of one of our circles. So if we multiply that by 5.5, we get 18 pi. So the answer is therefore D.
Okay, so you started off this question not really by working out the area of the circle at all, but you knew that there were 7 circles in total, but you had to subtract a certain amount because they've been cut out by these heptagon. And you know that the internal angles of a heptagon is 900.
Yeah.
So you had to do 7 circles, which is 2,520, minus the 900 degrees of the internal angle of a heptagon. And then that's the equivalent of having 5.5 circles. And then you worked out each circle and then multiply by 5.5. So really, it didn't really make a difference what shape this heptagon would be. Because if you increase the angle of one heptagon, well, you'll have to decrease the angle of another side. So it doesn't really make much difference of, well, not for this question anyway, about what the angles of the heptagon were. Very nice.